Hello there! In today's video, we are going to discuss algebraic expressions, what they are, and learn how to solve problems using algebraic expressions. Let's get started! First, let us understand what algebra is. Algebra is a branch of mathematics which deals with numbers, letters, and mathematical operations. Any mathematical problem can be represented in words using algebra. Similarly, word problems can be translated into meaningful mathematical expressions with the help of algebra. To do so, we can make use of algebraic expressions. An algebraic expression is a statement that consists of numbers, letters, and mathematical symbols, like addition, subtraction, division, or multiplication, together. An algebraic expression can have more than one mathematical symbol, but it does not have an equal sign. To fully understand the uses of algebraic expressions, let's take a look at an example. Peter needs to buy snacks for his sister's birthday party. He buys 5 bags of chips at an unknown dollar amount each, and 2 ice cream tubs for another dollar amount each. Since we don't know how much the chips and ice cream tubs each cost, we represent the cost of the chips with a dollar sign next to the letter C for chips, and the cost of the ice cream tubs with a dollar sign next to the letter T for tubs. How much does he spend in total? Let's break up this problem into steps. First of all, we know that a bag of chips is worth the amount represented C dollars. He buys 5 bags. Therefore, the total amount he would spend on chips is C dollars plus C dollars plus C dollars plus C dollars plus C dollars equals 5C dollars. Another way of looking at this could be 5 times C dollars equals 5C dollars. Next, he buys 2 ice cream tubs at T dollars each. In the same way, we can find the total amount spent on ice cream as T dollars plus T dollars equals 2T dollars, or 2 times T dollars equals 2T dollars. We now need to find his total expense on snacks. To do so, we can simply add up how much he spent on chips and ice cream individually. This would give us 5C dollars plus 2T dollars. So our algebraic expression is 5C dollars plus 2T dollars, or dollars parenthesis 5C plus 2T end parenthesis. Hence, Peter spends dollars parenthesis 5C plus 2T end parenthesis on snacks. 5C plus 2T is a classic example of an algebraic expression. Notice that it has numbers 5 and 2, letters C and T, and a mathematical operator, the addition sign. Let us extend this problem a little bit more. On the way home, Peter has to pick up 1 birthday cake. To represent the cost of the cake, we'll write with a dollar sign next to the letter K. So, he spent K dollars on the cake. K dollar, or 1 times K dollar equals 1K dollar. In an algebraic expression, if the number in front of a letter is 1, we need not write the 1 at all. In other words, 1K dollar and K dollar have the same meaning. Therefore, his total expenses would now be dollar parenthesis 5C plus 2T end parenthesis, and in addition, 1K dollar. We can combine these two expressions to get dollar parenthesis 5C plus 2T plus K end parenthesis. Can you see what we did here? We took a real-life situation and converted it into a mathematical expression. We are going to work with more such problems over the course of this video. In this video, we are going to cover the basics of algebraic expressions, which includes identifying the most important parts of such an expression, simplifying algebraic expressions, and evaluating these expressions. If you are new to this, don't worry. We are going to explore these topics with a lot of examples to help you understand better. Let's get started with the first one. We are now going to look at the different parts of an algebraic expression. In the expression 6x plus 5, 6x and 5 are called the terms of the algebraic expression. The addition sign in between is the mathematical symbol used in this particular expression to show that 6x and 5 are getting added. Moreover, the terms in the algebraic expression are separated by mathematical symbols. Depending on the number of terms in an algebraic expression, they might have different names. X is a variable. In mathematics, we use letters as variables to show that their value is not known to us. Variables can take up any value. The number which appears along with a variable is called a coefficient. In the above expression, 6 is a coefficient, and it is being multiplied by the x. Usually, the coefficient is written before the variable and not after. For example, in 6x and x6, the coefficient is 6 and the variable is x. Even though 6x and x6 mean the same thing, we always write the coefficient before the variable. A variable may or may not have a number written along with it. When a variable does not have any visible coefficients, the coefficient is assumed to be 1. For example, 1x and x mean the same thing. The 5 in the expression is called a constant. Because it has a fixed value, all numbers which appear individually in algebraic expressions are constants. There you go. Those are the 4 main parts of an algebraic expression. As we mentioned a little while ago, the number of terms decides the type of algebraic expression. Let us now look at the different types of algebraic expressions. A monomial algebraic expression has only one term. A binomial algebraic expression has 2 terms, just like the ones we were looking at a while ago. A polynomial algebraic expression has more than 2 terms, with some of the variables having exponents. In some instances, there may be more than one variable multiplied together. You should keep in mind that remembering the name of a certain algebraic expression is not particularly important. We use the definitions given above simply to help us identify the number of terms in the algebraic expression. Let us now take a look at some examples to identify the variables, constants, and coefficients in algebraic expressions. The first example is 3x plus 5. In this expression, there are 2 terms present, and the plus sign is the mathematical symbol used to show that the terms are being added together. Observe that there are 2 terms in this expression, making it a binomial algebraic expression. As we had mentioned a little while ago, figuring out the number of terms in an algebraic expression is important, but naming it, not so much. We can now recall the definitions of the various parts of an algebraic expression to try and identify them here. The letter used here is x, so that is the variable. Next, we have a 3 along with the x, making that the coefficient. Finally, we have the number 5, which is the constant. In summary, the parts of this algebraic expression are variable, x, constant, 5, coefficient, 3. Let us take a look at the example from the real-life situation we had worked on in the very beginning. We are going to make use of the same rules here as well. For starters, we can see that there are 2 mathematical symbols present giving us 3 terms in the algebraic expression. The letters in this expression are C, T, and K. These are the variables. Finally, let us take a look at the number appearing with the variables. With C, we have a 5. With T, we have a 2. Hence, we have two coefficients so far, 5 and 2. With K, we do not have numbers present. Remember that when a variable does not have any visible coefficients, the coefficient is assumed to be 1. So here the coefficient of K is 1. Therefore, our coefficients are 5, 2, and 1. There are no numbers appearing in the expression individually, meaning that there are no constants present. In summary, the parts of this algebraic expression are variable C, T, K, coefficient 5, 2, 1, constant, none. Let us move on to a third example. There are 3 terms in this algebraic expression, separated by the minus and plus signs. There are 2 letters present, n and x. Hence, these would be the variables. To identify the coefficients of this algebraic expression, take a look at the numbers multiplying the variables. For n, the coefficient is 1, and for 4x, the coefficient is 4. Finally, the only number which appears here on its own is 15. Since the 15 here appears after the minus sign, it would mean that the constant is actually negative 15, and not simply 15. If the 15 were to appear after a plus sign, like we had in the previous examples, positive 15 would be the constant. Therefore, the constant in this algebraic expression is, in fact, negative 15. To sum up the parts of this algebraic expression, variable n, x, coefficient 1, 4, constant, negative 15. Let's try another example. This particular example does not have any mathematical symbols in it at all. Hence, this particular algebraic expression has just one term. Still, we can now move to identify the parts of this expression in the same way as before. There is only one letter here, which is the n, and that is our variable. There is a 2 multiplying the n, so 2 is the coefficient. There are no individual numbers appearing in this algebraic expression, which means that there are no constants. Let's sum up the parts of this algebraic expression. Variable, n, coefficient, 2, constant, none. Let us take a look at one last example before we move on to the next topic about algebraic expressions. While this expression might look very different from our previous examples, we can still apply the same rules as before. There are 3 terms in this algebraic expression separated by 2 plus signs. Note that there are 3 different variables present, x, y, and z. Unlike the previous examples, these variables are not multiplied by any number other than 1. So, the coefficient for each variable would be 1. There are no individual numbers present, so there are no constants. Therefore, the parts of this algebraic expression are variable x, y, z, coefficient 1, 1, 1, constant, none. Even though these examples were quite different from each other, we can still apply the exact same rules to identify the different parts of the algebraic expression. If an expression looks too complicated, don't worry. Simply try to recall the definitions of variables, coefficients, and constants. And no matter how big or small the expression is, you should be able to identify the different parts of it just fine. Now that we are familiar with the parts of an algebraic expression, let us take a look at how we can simplify these expressions. An algebraic expression may be made up of multiple terms and might look unnecessarily long or complicated. In some cases, it is possible to simplify the expression by reducing the number of terms. There are 2 main ways of simplifying algebraic expressions. The first one is the distributive property. If the algebraic expression has parentheses in it, we need to distribute the term outside the parentheses to each term inside the parentheses by multiplying them individually. We call this the distributive property. Consider the algebraic expression 5 parenthesis x plus y end parenthesis. In this expression, the terms outside the parentheses is 5, and the terms inside the parentheses are x and y. Our goal is to get rid of the parentheses in order to simplify the algebraic expression. We begin by multiplying the 5 with each term inside the parentheses, thus giving us 5x and 5y. In other words, we distribute the 5 to the terms inside the parentheses. Therefore, we end up with 5x plus 5y. The second way of simplifying algebraic expressions is combining like terms. In mathematics, like terms means terms which have the same variable or have variables with the same exponential value. Like terms can be combined using addition and subtraction. An algebraic expression can have 2 or more like terms. Combining them helps us to simplify the like terms into one single term, simply by adding their coefficients. To understand this, let us take a look at a couple examples. In the example here, 5c and 2t are two terms of the algebraic expression having two different variables, so they are not like terms and cannot be combined together at all. This algebraic expression cannot be simplified further. Consider the expression 3x plus 4x plus y. There are two variables in this expression, x and y. There are 3 terms present. Out of the 3 terms, the 3x and 4x have the same variable, which is x, so they are like terms. The other term, y, has a different variable, so it is not a like term. Since 3x and 4x are like terms, we can combine them together by simply adding or subtracting their coefficients. The coefficients in this case are 3 and 4. Combining them would give us 7. So this algebraic expression can be simplified to 7x plus y. And those are the two main ways of simplifying algebraic expressions. Depending on the kind of algebraic expression we encounter, we might have to use one of these methods or both to simplify it. Are you ready to find out how we can use these tools to simplify complicated algebraic expressions? Without further ado, let us now move to some examples. Our first example is 5 parenthesis 3 minus 2x end parenthesis. Since we have parentheses in this algebraic expression, we need to distribute the term outside the parentheses to the terms inside. Here we have a 5 outside the parentheses, while 3 and negative 2x are inside the parentheses. To apply the distributive property, simply multiply the 5 with 3 and negative 2x individually. 5 multiplied with 3 is 15, while 5 multiplied with negative 2 is negative 10. The negative 2 also has a variable, x, along with it, so we need to include that too. Therefore, the simplified algebraic expression after applying the distributive property is 15 minus 10x. Let us try a second example. This particular algebraic expression does not have any parentheses, but it does have two like terms, 7n and negative 2. These are like terms simply because they have the same variable, n. To simplify this expression, we just need to combine the coefficients of the like terms. Here, the coefficients are 7 and negative 2. Combining them gives us 5. Therefore, the simplified algebraic expression is 5n. For the third example, consider the algebraic expression 7x plus 2 plus 3x minus 1. This algebraic expression has 4 terms, but 2 different types of like terms. Here, 7x and 3x are like terms because of the same variable, x. On the other hand, 2 and negative 1 are like terms, simply because they are constants. You can write the two pairs of like terms together. Combining the 7x and 3x gives us 10x, while combining 2 and -1 gives us 1. So the simplified algebraic expression is 10x plus 1. The original expression had 4 terms, and simplifying it helped us to reduce it to just 2 terms. For the next example, let us look at a slightly different type of algebraic expression. This algebraic expression has 4 terms too, but the variables have exponents. But that's not a cause for concern, because all we need to do is combine the terms with similar variables or variables with the same exponent. Here, x squared and 3x squared are the like terms, whereas y squared and 2y squared are another pair of like terms. Rearrange the 4 terms of the expression so that the pairs of like terms are together. The coefficient of x squared is 1, while 3x squared has the coefficient 3. So combining the coefficients of these two terms gives us 4x squared. The terms y squared has coefficient 1, while 2y squared has the coefficient 2. Combining these two terms gives us 3y squared. In the final step, we just need to place the simplified terms together. Hence, the simplified algebraic expression is 4x squared plus 3y squared. For the next few examples, let us look at how we can use both the distributive property and the combination of like terms in the same algebraic expression. Take a look at our 5th example. To simplify this expression, we need to first get rid of the parentheses by multiplying the numbers outside with the terms inside the parentheses. So we'll multiply 3 with 6n, giving us 18n, and then 3 times 1, giving us 3. Next, we'll multiply the -2 with 7n, giving us -14n, and -2 with 3, giving us -6. Writing down all these terms gives us 18n plus 3 minus 14n minus 6. At this point, we have an algebraic expression with 4 terms. There are 2 pairs of like terms, the 18n and -14n, because they have the same variable, and the 3 and -6, because they are both constants. We can rearrange the terms so that the like terms are together. Combining 18n and -14n gives us 4n, and combining 3 and -6 gives us -3. Finally, we would end up with the terms 4n and -3. There are no like terms remaining because 4n has a variable, n, and -3 is a constant. Hence, the final simplified form of the algebraic expression we started with is 4n minus 3. Let us take a look at some more examples which involve both the methods of simplification. In this algebraic expression, we have 3 terms. Here, the second term has parentheses, but the other 2 do not. Let's start in the usual way, multiplying the number outside the parentheses with the terms inside. This means multiplying 4 with 1, giving us 4, and 4 with -2a, giving us -8a. After applying the distributive property, we end up with 4 terms. The algebraic expression is now 3a plus 4 minus 8a minus 5. Notice that the simplification using the distributive property gave us 4 terms, which is 1 more than the number of terms we had started with. Distributing the 4 allows us to now continue with the simplification process by combining. In this step, there are 2 pairs of like terms, 3a and -8a. Because they have the same variable, a, and 4 and negative 5 because they are constants. Let's rearrange the terms so that all the like terms are placed together, combining the coefficients of a, which are 3 and negative 8, gives us negative 5a. Combining 4 and negative 5 gives us negative 1. We are left with two terms now, negative 5a and negative 1. These two terms cannot be simplified further because they do not have any variables in common. So the final form of this algebraic expression is negative 5a minus 1. We now move on to a slightly more complex algebraic expression. That's the longest algebraic expression we have seen so far. But don't worry, all we need to do is apply the same rules of simplification as before, and we'll be done in no time. Let's begin by applying the distributive property. There are two terms involving parentheses in this expression, so we need to simplify those first. First, multiply the 3 with the terms inside the parentheses. In this instance, we have three terms, x squared, x, and 3. Multiplying 3 with x squared gives us 3x squared. Next, multiplying 3 with x gives us 3x. Finally, 3 times 3 gives us 9. So applying the distributive property on the first set of terms gives us 3x squared plus 3x plus 9. Take a look at the terms 3x squared and 3x. They both have x as the variable, but in 3x squared, x has an exponent of 2, while 3x does not have x raised to any power. Even though the variable is the same, x, we cannot combine these terms because of the difference in the exponent of x. Now, let's use the distributive property on the second term with parentheses. Notice that 5x has a minus sign in front of it in the expression, which means we will multiply the terms inside the parentheses by negative 5x. When we use the distributive property, always pay attention to the signs. So we'll multiply negative 5x and 2 and negative 5x with negative 7x. Negative 5x times 2 gives us negative 10x. Watch this next part closely. Negative 5x times negative 7 gives us 35x squared. This is because we multiply the coefficients to give us a positive 35, but we also need to multiply the two x's together to get x squared. Be careful not to miss out on the multiplication of variables if you ever come across a situation like this one. So our final simplified term is negative 10x plus 35x squared. At this stage, we now have 6 different terms. Try to identify the like terms. If you look carefully, you should be able to spot 3 pairs of like terms. The first pair involves terms with x squared. These are 3x squared and 35x squared. The next pair is 2 terms with a variable x, 3x and negative 10x. Finally, we have the constants, 9 and 14. Let's rearrange the terms so that all of the like terms are together. The algebraic expression should look like 3x squared plus 35x squared plus 3x minus 10x plus 9 plus 14. You are free to rearrange them in any other way you like, as long as the like terms are together. Let us now proceed to combine the like terms. First, we add up the coefficients of x squared, which are 3 and 35, to get 38x squared. Next, we move on to the coefficients of x, which are 3 and negative 10. Since they are of opposite signs, we would be performing a subtraction resulting in negative 7x. Finally, we just add up the constants, 9 and 14, to get 23. Now, we have 3 different terms, 38x squared, negative 7x, and 23. We do not have any like terms anymore, so this expression cannot be simplified further. Therefore, our final expression is 38x squared minus 7x plus 23. Phew, that was a long and complex example. We had to work with a lot more terms than usual, but the steps we followed were the same as our other examples. Don't worry when you come across long expressions like the one we just did together. Just remember to use the distributive property and combine the like terms, and you'll be able to simplify it in no time. Great work today! In this video, we learned a lot about algebraic expressions. We learned about the different parts of each expressions and what they mean. We also learned how to work with them and simplify them. Next time, we'll learn how to evaluate them and even how algebraic expressions could be applied to real-life situations. Don't worry, if you don't feel completely comfortable with them yet, algebra takes a lot of practice. If you need extra help, remember you can always ask a teacher or tutor. Thank you so much for watching this video, and we'll see you again soon!